Hello and Assalamualaikum. Today we are going to proceed to 1.3 Homologous Series. So what is Homologous Series? It is a series of compounds which all contain the same functional group. If this one is alcohol, it means all have OH group or hydroxide. And each members differs from the next member by a constant CH2 unit. Okay, what does that mean? It means that if you have the simplest form of alcohol, which is CH3OH. Oh, sorry. What happened to this pen? CH3OH. Okay, so the next member is differ by a CH2 unit. So CH3, CH2OH. Okay, so this one is one carbon alcohol. So this one is actually methanol. This one is two carbon alcohol, which is ethanol. Okay, and the next member will differ by another CH2 unit. So this one is CH3CH2OH, and this one is propanol. Okay, so that is homologous series. A series of compound which contain all the same functional group, same functional group, same functional group, same functional group, and each member differ by the next member by a constant CH2. Okay, and differs by another CH2. Member of the same homologous series are called homologs. Characteristic of the homologous series. It have the same general formula. For example, alkane here, CnH2n plus 2. So let's say n equals to 1. So this one will be CH2n, 2 times 2 is 2 plus 2, 4. So this one for alkane. When n equals to 2, this is n equals to 1. When n equals to 2, it will be C2, okay, C2, 2 times 2 is 4, so 4 times 2 is 6, H6. Okay, so that is when n equals to 2. When n equals to 3, the same thing, n you change into 3, this one you change into 3, so C3, H, 2 times 3 is 6 plus 2 is 8. Okay, so this is alkane, this is alkane, this is alkane. So it have a general formula, applies to all compound in the same series. For example, alkane, CH4, still CnH2n plus 2, C2H6, still alkane, still follow the same formula, CnH2n plus 2, C3H8, still follow the same rule of CnH2n plus 2. Okay, so that is what it means. Physical properties. The larger the molecule, the stronger the intermolecular forces. That's why when you go through the homologous series, the few carbon atom, for example alkane, let's say you have CH4, let's say you have CH4. CH4 is, it might be gas, okay, it might be gas, and also C2H6. Okay, this one also might be gas. But when you go down the homologous series, the larger the carbon, let's say you have C5H12, okay, based on the formula of CnH2n plus 2, this one might be liquid. Okay, why it will become liquid? Because stronger intermolecular forces between the molecule. Okay, and so on. And maybe you will find C10, it become solid maybe. Okay, but you need to check the properties. We are not sure. But what I want to say is that down the homologous series, the larger the carbon atom, the physical properties will change gradually. It has similar chemical properties. Similar chemical properties means that if CH4, for example, CH4 can undergo reaction with Br2 under the presence of UV to become CH3Cl. It will be the same thing for C2H6. It will have the same reaction. UV. So this one will have CH2 H5 Cl. Okay, so it will have similar chemical properties. This is free radical substitution that can occur to CH4, which is alkane. C2H6 also alkane, so it can also undergo free radical substitution. This is free radical substitution. Same functional group, of course. It can have the same functional group. Earlier, I've told you about alcohol, OH. So every compound in the same series should have the same functional group. In this case, for example, hydroxyl. Okay, hydroxyl. So the one that is in the same group, CH3OH, CH3, CH2OH, CH3, CH2, CH2, OH. Okay, so all this in the same group can be prepared by similar chemical method. Okay, let's look for this one. Characteristic of homologous series have the same general formula. Okay, same general formula. So this one for alcohol. Alcohol will have the formula of this one, which is CnH2n plus 1 OH. Okay, 2n plus 1. So C1 when n equals to 1. Okay, when n equals to 1. Okay, C become 1. C1 H 2 times 1 is 2 times 1 is 3. So CH3 and then you put OH here. OH. Okay, so this one is correct for this one. Okay, what about when n equals to 2? When n equals to 2, C2H 2n. Okay, 2n plus 1. 2 times 2, 4. 4 plus 1 is 5. So C2H5 OH. Okay, at the end there you put OH. So this one is correct. Actually, this is a combined structure. Supposedly you should see it is like this: CH3, CH2, OH. But the same thing. Carbon is still 2. Okay, carbon is still 2. Hydrogen is still 5. 3, 2, 5. Okay, and one more OH. Okay, so that's what I mean. Has the same general formula. So CnH2nOH. It should also have the same functional group. For alcohol earlier, it should have the same functional group. When it have the same functional group, alcohol have hydroxyl group, so it can react with carboxylic acid to give ester. Okay, I can write down a simple form for you here. Okay, this is alcohol. R can be ethyl methyl propyl plus carboxylic acid R, maybe like this. R prime COOH. Okay, alcohol can react with carboxylic acid. This is alcohol. Can react with carboxylic acid. This is carboxylic acid. And it can produce ester. So ester is R O C O R. So this is ester. So all alcohol can undergo the same reaction. Okay, for example, let's say let's say ethanol. Okay, so R I change into this one, CH3, CH2, OH. Okay, this is ethanol plus, let's say this is CH3. Okay, ethanoic acid. So this is ethanoic acid. So it will become CH3, CH2, O, C, O, CH3. Okay, I hope you can see. So this one is actually R. This one is actually R prime. So this is the R. Okay, this is the R prime. Okay, so it should have the same chemical properties and same reaction. One more, it can also be prepared by heating dilute sodium hydroxide solution with appropriate alkyl halide. Reaction we are not going to learn yet. Okay, third one. Each homologous series differs from the homolog above or below it in the series by CH2. So earlier I've explained to you. So CH4, ethane, and this one. Okay, for ethane a little bit different lah. This CH4, because it is at the end of the compound. Okay, so by additional homologous series, you will see it only differs by CH2. This one also differs by another CH2. You add one more CH2, it become another compound in the same homologous series. So the same thing for this one and alcohol, so on. It shows a gradual change in physical properties. Like we discussed earlier, the larger the molecule, it means the larger number of carbon atom exists in the compound, the boiling point will increase. Okay, so the larger the number of carbon atom in the compound, so actually boiling point we expect for it to increase lah. In this case increase. Negative 162 is lower than negative 882 because the number here is negative. So it means this one is larger. It means that CH3 is larger in terms of boiling point compared to CH4. Okay, in terms of boiling point. So this is larger. Okay, so that's it about homologous series and characteristic of homologous series. I hope you can understand this topic and try to answer a few exercises that is being prepared for you. Okay, so that's it. Like and subscribe.